This video is brought to you by Bonita Soft. If you have any question, send them to jeremy.lambert@bonitasoft.com. All right, let's get started. Hello everyone and welcome to this webinar. Small introduction to start. My name is Pierrick and I do work on the Bonita platform for about 5 years, and my mission here is to facilitate the adoption. To do this, I am active on the community, doing some moderation, management, blog, forum, and contributions. I do create technical content like webinars, conference talks, and articles. And I do promote innovative approaches with other technologies like serverless that I will be discussing now. The first time I heard about serverless was about a few years back during conferences, but it is only for 6 months that I really took time to research, develop, and promote the use of this specific innovation. The purpose of this video is to give you an introduction of serverless, to better explain why and how to integrate it with Bonita, and to demonstrate with a real example. All right, let's start. Serverless was born 2 years back in 2014, but it really became a hot technical topic in 2018. You may have noticed a lot of content in the news and social medias, the creation of dedicated conferences around the world, a crazy number of dedicated libraries and this kind of frameworks, and also a lot of big players joining the game. Well, let's see why it becomes that trendy. And I will start with a few definitions. Well, to keep it short, serverless is all about abstracting servers and infrastructure on the cloud. There are multiple aspects of serverless, but I will be focusing on the specific case of serverless functions. What we call a serverless function is basically a piece of code that runs on ephemeral container. This is why you can run stateless functions on demand. Stateless because ephemeral, and on demand because on the cloud. On the cloud, we call this function as a service because it helps you to design and also to execute this kind of serverless functions. If you already know the common services on the cloud, you should recognize this pyramid. As you can see, the functions layer brings a new unit of scale. The abstraction is even higher than before, and it's right under the software, which is the latest part of this pyramid. This new function layer comes with a whole lot of advantages. At first, more abstraction means almost no operations left. It is outsourced to the cloud service, basically. Well, it is not currently possible to have no operations at all, but much can be automated, and this is done using some libraries and frameworks. Also, because it is running on the cloud, flexible scaling and high availability comes with no additional cost. It is basically part of the service itself. Serverless is synonym of distribution. We will see that after, but basically it is compliant with the new age of architecture. What I mean by new age of architecture is basically microservices and cloud native type of applications. And last but not least, with serverless, you pay based on function execution time and not per resource allocation anymore. This means that you do not pay for idle servers, which can be expensive when you have powerful nodes you need to keep running in case you have a peak of charge, for example. We've seen that there are a lot of advantages, but as you know, everything also comes with some drawback. What's wrong with serverless then? Well, the first issue is to be vendor locked in. To be honest, this is not an issue specific to serverless because it is true for any kind of cloud service. If you want to cut the risk, you can use dedicated cloud resources or open source projects to run your own private cloud. Also, it is the early days of the technology. So even if it is continuously improving, good tools and expertise are not easy to find. So that could be a drawback for your projects. Another issue is related to the ephemeral character of the serverless function. There is a limited execution time for serverless function to run. It's about 15 minutes for most of the cloud providers, and it has to be stateless. So all of that has to be taken into account during developments, which is not that easy. It is also true when it comes to the execution time of the serverless functions. The abstraction makes it fluctuates because of what we call the cold starts, and this can lead to issues depending on how you use it and develop. I really think that these issues related to the technology will be addressed pretty soon. The real pain is for the developer who will need to shift from centralized to distributed architecture and the associated tools and mindset. To better understand this, I illustrate the difference in these slides. This one shows a pretty basic monolithic architecture. This is the most common way any application is being developed these days. At least it was a few years back. Basically, the application is split into three main parts. The first one is the view, which is basically used by clients like browser, mobile phone, and this kind of things. It is for the end user display and input. So usually this is written in HTML, JavaScript, JSON, Android, iPhone, this kind of things. The second element will be the controller, which is used by the application server, like Tomcat or Wildfly. And it runs the business logic written, for example, in Java. And the third one is the use of a database like SQL or NoSQL. And the idea is to persist business and technical data. This is what we call the centralized approach. Here, what you're looking at is a pretty basic cloud-native architecture based on serverless. This is the new way an application is being developed, and it is becoming quite common. The application this time is completely distributed. So there is no application server anymore, as you can see, and this is replaced with APIs that are exposed thanks to what we call an API gateway. The business logic this time is completely distributed in many serverless functions. It's not centralized anymore. And the data is usually also being distributed in multiple or denormalized databases. What I show in these two slides are examples of pure centralized distributed applications, but it is much more common to encounter hybrids. Because these changes are structural changes, many teams will likely end up with a mix of styles of architectures in the system or for a specific application. This is what we call hybrid approach. When it comes to the use cases of serverless, basically we could use it to build entire applications. We just saw that in the last slide talking about distributed architecture. But serverless is really powerful when it is used in a specific way. The first one is when you trigger the serverless function from events. You will use that to do some analytics, monitoring, these kind of things. It's also super powerful when you trigger it from API calls. Here, what you will do is to somehow enhance the scalability of an existing application backend. You will be coupling the serverless functions and callable APIs to do that. And it will be also super useful to leverage cloud ecosystems. Cloud is coming with a bench of services that are super difficult to develop by yourself. I'm thinking about face recognition, flagging inappropriate contents, this kind of services that relies on AI or these kind of things that needs a lot of power or a lot of storage. Okay, so what about the cloud platforms that provide some function as a service? As I told you, all the big players are present. So we find obviously the main providers like AWS, Azure, and Google Cloud. But there are also big players like IBM, Oracle, and Red Hat, heavily supporting and leveraging open source serverless frameworks like OpenWhisk for IBM and FN Project for Oracle. Even yourself, you can use this kind of open source projects to deal with your own private cloud. And when it comes to the IDEs that are available for developers, well, there is no clear leader today. There are obviously a lot of plugins for Eclipse, JetBrains, Visual Studio, this kind of mainstream IDEs. And you can even find some cloud IDE. Sometimes they will be specific to the cloud provider, like AWS Cloud9, but some of them may even be cloud agnostic, like Sigma. Regardless of the ID and platform you use, most of them are based on SDKs and CLIs. Sometimes what you want is something that is agnostic and to deal with multiple platforms. This is where the serverless developer platform becomes handy. The idea is to provide some framework to develop functions across different cloud platforms. The second element of this developer platform will be to have a dashboard to graphically display the function executions that's been done on different clouds. And then there is a third element that is called the gateway that helps you to make legacy tools serverless. All right, so at this time, you should better understand what is serverless and what are the tools. Let's see why and how we can integrate with the Bonita platform. As you already know, many companies keep focus on business innovation to maintain or to gain competitive advantages. The Bonita platform tries to bring both business and technical teams together to continuously develop relevant business applications. When it comes to serverless, it is one of many approaches that can empower technical teams for better development. This is particularly true for the use cases that we already discussed. And sometimes you want Bonita to leverage serverless for these use cases.
I provide a few examples here on this slide just for you to better understand. So you basically recognize maybe this use case we already discussed about the ecosystem of the cloud. The second one is about the fact that you can trigger executions from your processes written in different languages. So this is something that is really important, and sometimes you will need that from the Bonita platform. Sometimes you also want to reduce the resource footprint of your Bonita server. You want to better scale and also reduce the cost of this server, regardless of the business that you're executing. Sometimes also you want to make sure that you provide all the tools to your developer, especially developers of your applications.
All right, so let's see how we can integrate Bonita with serverless. What we see here on the right is the Bonita platform on the top and the cloud service with serverless on the bottom. When Bonita tries to reach out with a serverless provider, what we'll be doing is to call a connector. This connector will run in a synchronous way or in an asynchronous way. So this is what you see on the right, the controller that will make the call using the serverless API. And on the other side, we have serverless that has to provide the answer to Bonita. As you can see on the right, if it's a synchronous call, it will directly return to the controller. But if it is an asynchronous call, then the controller will not get the response right away. What will happen is that this function on serverless may run for a few minutes and then call back Bonita using the callback API to provide the response. On this slide, I provide a reminder of what is synchronous and what is asynchronous. You need to keep in mind that there is no perfect option, but only trade-off. Each of them will have advantages and also drawbacks. If we make a synchronous call from Bonita to serverless, we will block a connector. So it's good because the execution is done on serverless and then it reduces dramatically the use of CPU resource on Bonita. But Bonita also opens and keeps an HTTP connection resource during all this time because the connector is waiting for the response. To avoid this issue, you can use the asynchronous mode, which only launches the job and then comes back. So this reduces, obviously, the time the HTTP connection resource will be used because we just make the call without waiting. But then the external system, which is serverless here, needs to call back Bonita. We have a network between the two systems, so anything may happen. And this means that developers will need to design with resiliency in mind. This includes a lot of things like duplicated calls, retries, timeouts, and so on. All right, this is it for the presentation part. Let's see what it looks like for real with a quick demonstration. I will show you how I managed to make such a serverless function, asynchronous call, from a process running on Bonita. First thing that I needed to do was to select a specific cloud provider for serverless. I did use AWS Lambda for many different reasons because there are plenty of runtimes and tools available. We can run in Java 8, Node.js, Python, C Sharp, and so on. There are a lot of SDKs, a lot of CLIs, APIs, anything you need to develop. But also because of the features, you can tune your serverless function or resources that you want to use. You can have 15-minute execution limit, which is quite big compared to some other providers. And there is the fleet deployment, which is kind of nice to have. And well, AWS Lambda is basically the leader. It is a quite large cloud ecosystem. So if you want to play around with some functions, you can do that. And it is pretty much free when you don't have so many calls to be made. So it's pretty nice when you want to do some tries like me. Okay, so I would go through all the steps. The first thing that I've done is to create the AWS account to make sure that I can run on the cloud. I did create my AWS Lambda function, and then I created my own Bonita connector and application, and then I made it run. So let's see how I did that.
Okay, so let's start with creating the AWS account. It is pretty simple. You just need to go to AWS website and you can create your account there. That's what I've done. And as soon as you do that, you can have access to the web console. And this is what you see on the screen. From this console, I have created a user, and I will be using this user to request a Lambda. So what I have done is to provide all the permissions to this user to leverage AWS Lambda service. To make sure that the Bonita platform will be using this user that I have created with all the permissions, what I will be doing is to add the credentials of this user for this account on my local environment, as that from this Bonita studio, I will be able to request. There is basically something that AWS provides. So if you go to the credentials file on the AWS directory, from there, you can just provide the AWS access key and the AWS secret access key. So that's what I've done here. Obviously, I just replaced the value to for security reasons. The main idea is to provide this on the file, and then you're good to go with AWS credentials, and the Bonita platform will be able to use it by default. Next step was to create the AWS Lambda function that I will be requesting from the process. For this, I basically created a Java project. When you write some AWS Lambda function on Java, what you will be doing is to extend a request handler that is provided with the SDK of AWS. And here I do something pretty simple. As you can see, what I'm doing is basically to return the request that I receive. And this is helpful to make sure we understand what's going on and to debug in case of error. As soon as I had this function implemented, I came back to my web console to create the Lambda function for it. Create function here, and you will see that you basically provide the name, the runtime, the role. It's already done. It's called example, and this example will be the function that will be requesting. What I just added is for the logs coming from AWS, which is coming with X-Ray and CloudWatch. So it's pretty basic, nothing crazy. If you see here, it's basically a Java 8 runtime, and the handler will be basically the class of my implementation. To make sure everything is running fine, I can just go to my function and run test. It takes some time because it's a cold start. And as you can see, this is what I provided, and this is what it did. So these are the logs. Everything is set up on AWS. The function has been implemented and has been deployed. And we also have credentials already set up on my local environment. We can connect and request this function from an application. What we want to do now is to make sure we have the Bonita artifacts deployed on the studio and make them run. So what I've done is to deal with the business logic, the business data, and the user interface as a regular application. I will be going through all of this in the studio to show you what I've done quickly, and then we'll make it run. In terms of business data, You can see that I just created a business data that is called Lambda result. This is just for me to keep track of the response. Then, as soon as I had this, I knew that I will create a process, and for this process to run and call the function that is a serverless function, then I needed to have a connector. So I created a definition, and this definition is called AWS Lambda. And this AWS Lambda is capable of calling a specific serverless function with AWS. So if I edit that, I will just show you quickly what I have. Pretty basic here. And you can see that I have few inputs. Most of them will be optional, but you definitely need the region and you definitely need the function name. Other things that will be used in the request will be the payload, obviously, that will be the input. The invocation type to know if it's a synchronous or asynchronous call, and a few other things that are not that important right now. This definition has been implemented. So I will just show you the implementation that I've done. As you can see, I provide a few dependencies. The main one is the AWS Java SDK Lambda, and this comes with a few other dependencies. So that's why I provide all of this here. If I finish, I will open the Java and I will show you what it's inside. In the execute business logic, which is the main method of the connector implementation, I basically have the client builder for the AWS Lambda, and this is using some of the input like the region. Then as soon as I have this client builder, I can generate the client, and I can generate also the request with all the inputs like the function name and the payload. And as soon as I have it, I can just invoke the request using the client and the request. It executes and then I get a result. I will use the result of this invocation to set all the outputs of my connector execution, as that I can use this information further in the process. I will be executing this connector as part of a main process. First thing I do is to make the request that is asynchronous. So I just launch the call. From here, I do the wait using a sub-process because I want to factorize this asynchronous wait. As soon as it's done, then it will be able to go to the third task of this process, which is basically to show and to display the results to the end user. If I go to the sub-process, what you can see is pretty simple. Actually, it takes information as part of the contract, like the callback ID, these kind of things. In this sub-process, I just wait for the callback, which is basically a message coming from the AWS Lambda. And then I set all the information about the results directly in the variables. In terms of interface, the only thing that we have is this task with an UI. Because we want to display the result, we just go with a really basic form that will show the business variable that we store in the process. So let me show you this form. If I go here and click on edit, you can see that I go to the context, and this Lambda response is just used to fill all the different text fields. If we come back to this process, I will just show you quickly the parameters that we have set up. I use the callback URL, which is my local IP address, and I need the name of the function, which is example, as we've seen. The invocation type is event, which means asynchronous in AWS Lambda. In terms of payload, I will just provide some dummy information just to test. And the region will be US East 1, which is the one that I used to create my function. And I have some timeout information here. You know everything, so let's run it now. All right, we can start it. This will go through all the job, and as you can see, we have this task already available. And this task is coming from a process and got a content back. Because of the implementation we've done on our function is basically providing the response as the request. Or a serverless function called back and provided this payload as a response. We are pretty good here. So if I come back to the web console, what we want to make sure is that the Lambda function executed. So we should see the logs. If I go to the CloudWatch logs, I should have a stream for my function. So I will go to logs here, This is the name of my function, and this is the latest one, so I will just select this one. All right, so everything went fine from AWS Lambda point of view. That's what I wanted to show you.
This is all I had for today's demonstration. As you can see, I provide all the demonstration resources on the GitHub repository. I also provide a series of articles that I have published on DZone if you want to go deeper into this subject. It was a really big subject today, and it was a really short time. It is also early days of this technology, but it is super exciting because of all these opportunities that we have to empower developers and scale. Also, we are working a lot on this type of integrations at Bonita. I will keep you posted as soon as I can. It is time for me to close this video. I guess I will talk to you pretty soon with another subject. Bye-bye.